What's going on, guys? It's Mr. Jones. I'm just here to talk to you really quick about Ready, Set, Go 1.7, which is this classwork / homework assignment for today. So go ahead and get out your comp books. You're definitely going to be taking some notes. I'll do 3 of the problems for you, give them to you for free, and then you should be able to do the rest. So go ahead and do that. Pause me if necessary. All right, so I can't stress enough that you need to read the directions. So make sure you read the directions so you always know what to do. These first four problems, 1 through 4, there's 3 answers that you have to give per problem, and you also have to fill in the blanks for any missing number. So let's go ahead and look at number 1. It says find the missing values for each arithmetic or geometric sequence. So obviously you're going to choose which one it is. Underline or circle whether it has a constant ratio or constant difference. And then state the value of the constant difference or ratio. And then indicate if the sequence is arithmetic or geometric by circling the correct answer. So several things that you need to do. Let's go ahead and do that together so you know how to do the rest. All right, let's go ahead and look at this first problem. Remember that we are always starting with the first term. So this would be term 1, term 2, term 3, term 4, term 5, term 6, and term 7. These are my x values and these are my y values. And so hopefully that helps out a little bit. All right, so looking at the y values of the outputs, we should easily recognize what we're doing every single time. And so hopefully you already have in your head before I say that we're adding by 5 every single time. So because of that, because we're adding by 5 every single time, we're going to go ahead and underline that this is a common difference, because common difference is what we use for arithmetic sequences, and that means that we're adding or subtracting every time. So common difference, and then it says what is the common difference or common ratio, in this case common difference, so we know that we are adding by 5 every single time. Okay, and then lastly it says, is it arithmetic or geometric? Well, since we have a common difference, we know it's arithmetic, and because we're adding every single time, we know it's arithmetic. So that's literally the entire problem. Oh, we forgot one more thing. We have to fill in the blanks here. And so since we're adding by 5 every single time, I can just add 5 to 15 to get 20, and then add 5 to 30 to get 35. All right. The next set of problems says, determine whether the given information represents an arithmetic or geometric sequence, then write the recursive and the explicit equation for each. All right, so the very first thing I want to do is figure out what this sequence is doing. So I chose number 6, so it'd be a little bit different than number 1. So right off the bat, I say, I could add 2 to get from 2 to 4, but then to get from 4 to 8, I'm not adding 2. So I must be multiplying. So this is actually multiplying by 2 times 2 times 2. And then you realize, okay, 2 times 2 is 4, and 4 times 2 is 8. What I really recommend doing is creating a table that looks like this, more similar to the ones that we've done in class. And you should actually have some x values there. So you only have 1 through 4, but you should be able to get whatever ones you want. Okay, so the first value is 2, and then 4, and then 8, and then 16. And we know we are multiplying by 2 every single time. And so that's good information. To go backwards and get the 0th term, you have to do the opposite of multiplying by 2, which is dividing by 2. And 2 divided by 2 is 1. And so that's 1. If I want to get my last term, I just multiply by 2, and so there's a table from 0 to 5. So with all that being said, hopefully you realize this is geometric. You know that because you're multiplying by 2. Okay, the recursive equation, I'm going to put R for recursive because those lines are real small. The recursive equation, hopefully you realize, always starts off with the current term. We call that f of x or f of n. In this case, I'll use f of x. So this is my current term, and then equals my previous term, and then whatever the heck you're doing every single time. So in this case, we're multiplying by 2, and so that's that. There's one more thing we need to put. We need to define a term. So just say, hey, the first term equals 2. So all of this goes together as the recursive equation. I always forget to define a point, but basically it's just saying, give me a point on the table that you know for sure is true. So I know the answer to the first term is 2, because that's right here. My first term is 2. Remember, this is current term. Write that down if you don't know. Previous term, common ratio. Okay, current term, previous term, common ratio. All right, there's the recursive equation. The explicit equation we know is in the form a times b to the x. Or I'm not sure if Mr. Norman showed you this while I was gone, but this is using my 0th term. Or we can say, use our first term times b to the x minus 1. So I'll give you both equations just in case, and then whatever one looks familiar to you, you could use. All right, so let me move this really quick just so you can see a little bit better. All right, so here's my explicit equation. Okay, here we go. In the form a times b to the x, the first one right here, my a value is my 0th term, whatever the 0th term equals. So that's 1. Okay, so 1, you can see it right here in red. 1 times, and then b is my common ratio, 2 to the x. So basically you can write that as just 2 to the x. The 1 kind of disappears. So either one of these are the exact same equation. Or the other method, if you want to use your first term, you can say your first term, which is 2, and then times my common ratio to the x minus 1. So this equation would work, or one of these equations would work. So any of those equations would work for explicit. All right, if you're confused by that, go back to the notes on geometric sequences and how to get the explicit equation, how to get the recursive equation. You can always look it up online, but we've made videos for all of this, so make sure to take a look at that. All right, the last thing I want to show you is problem number 13. So 5 through 12 are all pretty much the same as the one I just did, number 6. The only difference is sometimes you have a sideways table, sometimes you have an up and down table, sometimes you have a word problem. And number 12, I'm just going to give you a little hint. Number 12, I'm not sure if Mr. Norman taught you about percent increase and decrease, but to save you time on number 12, okay, on number 12, it's going to be geometric. And that 10% interest each year, that means that you're going to earn more money. So if you put money in the bank, if you look at number 12, you invest $6,000 into your account that earns 10% interest. That means you're going to gain money in the bank. So it's going to be geometric. You can't write on here, but it is geometric. And the common ratio is 1.1. So for problem number 12, it's geometric, and that's your common ratio. Okay, so you're going to go ahead and put that in for B in your equation. And then I'll let you guys do the rest. I'll know I put ration, but it's ratio, right? So erase that in, and we're good to go. All right, that was just a side note. All right, last thing is problem number 13. This is these directions are just really weird, but at the end of the day, it's just saying plot and label the 2 points on the graph, and then we'll do something else in a second. So let's go ahead and plot and label the points first. So 2, -1 would be right here, and 4, 2 would be right here. So this is B, and this is A. Now the next thing it wants us to do is sketch on the graph how you count the slope by moving up or down and then sideways. In other words, what's the rise over run? So rise over run, you guys learned before, is the same thing, not run, is the same thing as slope. Okay, we already know our slope is supposed to be 3/2, so we're just showing that that's actually true. So in purple, you're just going to show 1, 2, 3. There's my 3. 1, 2. There's my 2. And they're both going in the positive direction. So my rise is 3 and my run is 2. And you're just basically showing that on the graph. So something like what I just did. Okay, something like what I just did. You could also draw lines there. So if you don't want to draw the little arcs, you could just draw lines and kind of make a triangle instead. So you can turn this into a line and this into a line. And either way, you need to label the rise and run. But basically, there's your rise and there's your run. All right, guys, so that's pretty much it for all these problems. Let me know if you guys have any more questions. Just send me an email or come to office hours, guys. I promise you, if you come to office hours, it's going to help you so much. All right, have a great day, guys.